So today we actually, okay, I mean yesterday, sorry. So yesterday we actually talked about, not this. Yes, yesterday we talked about what? These ones. So we said that ionic compounds come in two kinds. Either what? Who can say this word? Come on. Short word. Binary. Binary means what? Only how many elements are involved? Two. Only two elements involved. A metal from, so where are the metals? Are they on the right side of the periodic table or the left side of the periodic table? Metal, no? Yes, yeah, the lithium, calcium, sodium, all of these. And also the second column. And the non-metal. Where are the non-metals? On the complete other side, after the big box, yellow box in the middle, okay? Examples are NaCl, Na, sodium, Cl, chlorine, LiO2, Li is lithium, O2, even though we have two of it, but we still have two elements. It's the Li and the O, so lithium and oxygen, okay? The other ones are those ones called what? Who can say this word? Break it down. What's this word? No, too much. What's this word? Poly. Just this word. Poly, yes, poly. And what's this word? This one. Atomic. Polyatomic. 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 What does that mean? You've got more than what? Two elements. Like what? Do you remember what Ca is? It's in your bones. Calcium. Nice. Alipio, yes. What's S? Just S, not SO. There's no SO. There's just S. Sulfur, the thing that makes explosive and gunpowder and all that. And what's O? So one, two, three things. Okay. How about this one? What's N? Nitrogen, which sometimes you breathe. Hydrogen. And again, what? What about this four and this two? Don't worry about these. These will cover either tomorrow or next week. Okay? All right. And I said that there's so many examples of these. To tell you quickly, ammonium is everyone listen up. Ammonium is very common in cleaning products. Ammonium, if you look at if you walk right now, uh, yeah, you could. If you walk right now to the custodian closet, you know, where they keep the cleaning products and stuff, and you just smell, that smell you smell in any custodian closet, wherever they keep the cleaning products, that smell is actually what? Who can say this word? Ammonium or ammonia. Yes. A lot of cleaning products, even in your house, but mostly the industrial ones that we use to clean schools, your stores, and that kind of restaurants, are actually loaded with ammonia. Very dangerous. If you drink it or if you inhale too much, you could faint and doze off. And actually, well, if you suffocate, that's it. You're gone. Um, do you remember where these are? Nitrogen is very important to what? To what? Not us, but to what? To plants, trees. Trees need nitrogen to exist. If everyone, if you have a plant right now and you put it in a soil, if you put it in a soil, like in some, like dirt and mud and whatever, if this soil, everyone, if this soil right here has no nitrogen on it, sorry, in it, you could give it as much water you want, you could give it as much sunlight you want, you can give it as much air you want, that plant will barely grow. Plants need nitrogen. And where do they get the nitrogen? From the what? From the underground. They are actually, by the way, when you plant a tree, when you plant anything, what goes into the ground and keeps going and going and going? Do you know what we call it? Come on, what does every tree have? On the top side, it has what? A trunk and branches. What does all plants have at the bottom? Come on. Noah, do you know? What do trees have at the bottom? Hmm? Roots. Roots, right? Roots. They dig into the ground, right? That's why it's very hard to take a tree off because they have a lot of roots and they're just way too deep. Okay? These roots keep going and the nitrogen that gets into the roots. Okay? But they have to go deep. Okay? There's no nitrogen at the surface. There's no nitrogen on the grass, but there's nitrogen deep down. Okay? So plants really need nitrate and nitrite because they're full of nitrogen. Also, you can just put some topsoil on it and give them a lot of nitrogen as well. What else? All of these ones are dangerous, by the way. By the way, why do you think all of these are dangerous? What's the common element in all of them? Come on. Mona? Oh, no, come on, folks. What's the common element in all of these? 1, 2, 3, 4. Come on. What are the only two elements here? Chlorine and oxygen. But which one is dangerous? Oxygen is not dangerous. Which one is dangerous? Yeah, if you have any solution or any product with hyperchlorite or chlorite or chlorate or perchlorate, again, very, very dangerous. Do you remember what I said about this one yesterday? Cyanide, not cyanide. Do you remember why I said where they use it? Does anyone here watch like James Bond and spy movies? Do you know James Bond? Yeah, James Bond is the most famous British spy. Okay, so back and okay, in the 50s and the 60s, when there were a lot of spies, in England, in the States, in Germany, and so on, spies used to have a cyanide pill, just like an Advil, but it's a pill like this, with them, because if they get caught by the enemy and they do not want to release secrets or to be, like tortured, they're like, all right, I don't want to get tortured, and they just swallow it, swallow a pill. That pill is so dangerous. Within 1 minute, they're dead. So again, it 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 was sometimes they were sometimes told to do that because they had so many important secrets and they did not want the other enemy to know them. So they're like, if you get caught under torture, everyone will say everything, right? If you keep if you keep beating someone up, at the end they will tell you what you want. So they were like, you know what? No, that's it. I'm just gonna swallow the pill and then that's it. Within 1 minute, I'm gone. Okay. So that's what cyanide is for. It used to be like that. Okay, very, very, very powerful assassination or like killing device. Okay, ammonium acetate. There's a lot of acetate in your body. Phosphate, hydroxide, and sulfate. All of that. Okay. All right. We'll cover these in the next couple of days. Okay. All right. I think. Oh, sorry. Yes. Okay. Do you remember what we did with this yesterday? What did we do with this? Did we sketch it? Do you remember how I told you to sketch a box or what do you call it? What do you call a perfect box? Starts with a C. What do you call a perfect box? A box that has all the faces. Where's my? Yes. What do you call it? Yes, that is. This a perfect cube? No. This really? Do you think so? No, it's not a perfect cube. Why? Is this face right here, everyone? This face. Is it a perfect square or rectangle? Yeah. Sorry. One face is rectangle. That's it. The whole thing is just a box. This is a rectangle. This is a rectangle. This is a rectangle. This is a rectangle as well. Could this almost be like a perfect square? But I don't care. All of them have to be squares for it to be a perfect cube, which is just like that. When you mix Na with Cl, you actually make them combine in a perfect cube. Perfect cube. Okay. This is one cube. This is another cube. This is another cube. This is another cube. Okay. Always remember one thing. When Na and Cl combine, you always have a green circle. And what's next to it? Green next to what? Red. Always. Every green is next to red, and every red is next to green. The green ones are the Cl. By the way, they're not green. It's just a color thing to tell you which is which. The green ones or the big ones are the chlorine, and the small red ones are the sodium. Okay. Why? Why do they always bind or attract or stick to each other like this? Because the positive and the negative always want to be what? Together. Positive and negative always go together. Okay? Yes, and if you have a large number of ions, you can build bigger and bigger and bigger and bigger compounds. Okay? Sometimes that's good, sometimes that's bad, depends. Ionic compound always have a net charge of how much? Why? Because every negative here will be canceled by a what? Every pair will cancel. Negative positive will be zero. Negative positive, negative positive, positive negative. All of them will just cancel. Okay? All right. So examples, calcium fluoride and aluminum oxide. Okay, let's actually sketch each one of these two. All right? So ionic compounds. Okay. So I think, do we have a second page? Yes. Okay. All right, everyone. Let's do this page. So let's go to this page right here. Okay. So everyone, let's do the example. Calcium fluoride. Calcium fluoride. Okay. So what are we going to do with this? What's the symbol for calcium? Ca. So symbol for calcium is Ca. So let's just write C. Okay, actually, don't write anything. Everyone pencils down. Let me write the whole thing because I'm not sure exactly how much space I'm going to need, so I don't want you to keep erasing. So let me write the whole thing, and then I'll give you a lot of time to copy. So calcium is Ca. And fluoride did not used to be called fluoride. It used to be called what? Remember, we added IDE because it's an ion. What was it called before being called fluoride? Come on. Okay, remember chloride? What was chloride before? Uh-huh. It was not IDE. IDE is when you combine it with something. On its own, what is it? What did this used to be? It was not IDE. Come on. Fluorine. It used to be INE. Okay, so if you go right now here, if you go to Google, for example, and you write fluorine, there we go. Yes, fluorine is this element right here. Yes. Uh-huh. There we go. Fluorine. Do you remember where fluorine is important in your what? When you brush your teeth, your toothpaste should have some fluorine, not a lot. If you have a lot of fluorine, your teeth will become yellow. They will not get weaker. No, they will just change color. So too much fluorine is not going to make them weaker or fall. It's just going to change your smile. You're going to have yellow teeth, but your teeth will still be strong. Okay? So this is fluorine. So, okay. So fluorine, what's the symbol? F. What's the number for calcium? What's the number for calcium? Day 4. There we go. Maybe this. Yes. What's the number for calcium? 20. Okay, 20. So what does this mean? It means I need as many 20 electrons as I can sketch here. So you know what? Let me, what's going on here? Oh, it's cut. All right, I'm going to fix that after. Just give me 1 second. I'm just going to take this out down here. And this one down here. Yes. Okay, let's sketch some circles. I need 20. So, okay. Here's 1, here's 2. Here's another circle. I know they're bad circles, but whatever. 1, 2, 3, 4, 5, 6, 7, 8. 2 plus 8 is 10. I still need 10 more. 1, 2, 3, 4, 5, 6, 7, 8. No, not 4 more. Come on. How many do we have so far? 2 on the first circle, 8 on the second circle, 8 on the last circle. How many? We have 18, but we need to go up to what? 20. So I need another what? I need one more circle. One more circle, but with how many? 2. So I'm going to put them right here. Okay, now let's do fluorine. What's the number for fluorine? Fluorine is much smaller. It's actually just what? Just how many? 9. Okay, that's got to be easier to sketch. Here's 1. Here's 2. Here's 1. Here's 2. Here's 3. Here's 4. Here's 6. Oh, sorry, 5, I mean. 6. 7. Yes. Let me just finish this one. Okay? That's it. What's 2 plus 7? 9. So we finished it. Okay? Now, can you tell me what should this one do? By the way, it has 2 electrons on the last circle. Should it gain or should it lose? By the way, remember, they want to be full. But sometimes to be full, you don't have to gain. You can lose. Yeah, I can give. But I can give how many? I can give 2. Why 2? Everyone look. If you give this one, if you give away this one, And also what? This one. Do you even need the last circle? Perfect. Which means what? Do you have how many circles now? 3. And are they all full? Yes, they are. You see, sometimes to be full, so especially if you have what? A few number of electrons at the end, you can just what? You can just get rid of them to go what? To go less and full. Less and full. Here's my question to you. What is this one going to do? How many electrons does it have on the last circle? Come on. 7. Ooh. Almost what? Almost 8, right? So what should it do? Lose 7 or gain 1? Yeah, I don't. Losing 7 seems a lot of work, like a lot of work. Gaining 1 is a what? Is much less work. So what does this mean? What does this mean? It needs to gain 1. But here's one thing. Everyone, look. How many did this one lose? How many does this one need to gain? Okay, pencils down. I just want you to think about this with me. This one can lose 2. Okay, let me actually give it to you another example. Okay, everyone. I have some money, but it's too much for me. Okay? I want to give some money away. But I only can give how many dollars? $2. All of you can get that money, but the only amount you can take from me is what? $1. But I have how many dollars to give? So if I just give it to Muhammad, you only took how many? You cannot accept, for some reason, you cannot accept more than. So I gave you $1. I still have how much to give? $1. So what should I do? I cannot give you 2. You can only accept one. I can't keep it. That's my thing. I need. But no. You have to understand. Chemistry, you cannot just throw electrons away into nothing. You have to give them to something. I gave you 1. I still have 1. Yes, Mana. No. You know what? Very interesting. I cannot break up an electron. It's like I have a loony and a loony, and I have to give the full loony to a full person. So I gave you 1. What should I do with the other one? I can't keep it. That's the thing. I have to lose these 2. I have to. You know what? I have some money here from like last year. Yes. So let's say I have these 2 coins. Okay? I can't keep this on me. I need to lose it. So what should I do? You're all thinking too much. Nope. So say again? Yes, I have to choose someone else to give it to. Is it making sense now? I have to give the 2. But you can only accept what? You can only accept what? You can only accept what? You all can just accept 1. Which means I have to what? I have to choose 2 lucky people to give what? 1 to each. Is it making sense now? No, see, okay, you're very good question. But come on, when you react chemistry, do you react small amounts or always a lot of things? You have always a lot. Like when I give you, if I give you right now this much powder of NaCl, I'm not just giving you this much powder. I'm giving you a lot of atoms inside of it, right? So don't worry. There's always gonna be what? A lot of people to choose from. But that's my point. I am happy now because I lost my what? My 2 coins. And you're happy now because you got how much extra? And you got how much extra? So I am happy because I lost my 2, and you are happy because you each got what? Whatever I lost, you 2 what? Gained. You see the kick? I cannot just say, oh, I'm just going to give 1. No, if I'm going to lose the 2, I have to what? I have to find 2 people to give. Okay? Perfect. So my question to you is, if this one needs to lose 2, is it enough to lose to 1? I need to sketch what? Another one as well. Is it making sense? All right, so let's sketch another one. Hold on, let me sketch it quickly, and then I'm going to show you how to sketch the arrows. So I'm going to actually take F again. Okay, so one circle of 1, 2, and another circle of what? 1, 2, 3, 4, 5, 6, 7. Okay, We said what's going to happen to these two things? Are they going to stay or be given away? These two. I am the one losing, right? Where are they going to go? One is going to go where? Here. And this one is going to go where? Exactly. Alipio is this one. Muhammad is this one. I am this one. So I took 2 coins and I gave to what? To these two. 1 to each because they cannot accept more than 1. By the way, what happens if I gave you 2? You are fluorine, right? What happens if I gave you 2? That's going to be a problem for you, right? Yes, thank you. You're going to have to put it here, but then you're going to have to sketch another what? Another circle with how many electrons in it? 1. But that means that this last circle is not going to be full because you still need, do you see? That's the problem. You only accept as much as you need to accept. No more, no less. So what do we do here? I don't know. Okay, go ahead and sketch this. But before we do that, this is what we're going to do. We are going to take this one. Can you tell me where to put it on the top, fluorine? Where does it go? From here? Where? Yes. Right here, right? Yes. So I'm going to take, everyone, we're going to take this one and put it, I know, maybe here. Yes. And where does this one go? Yeah, same things are just on here. There we go. Now this one is full. And this one has lost these 2. Go ahead, come on. I'm going to zoom in so you can see it properly, hopefully. Yes. By the way, the next example, the aluminum with the oxygen, is going to be a bit more interesting. We're going to have to figure something out. But we will understand at the end, don't worry. I think I actually will need more coins. I think I have enough. Yes. Thank you. All right. Okay. Yes. Yeah, go ahead. One, two, three, 6. Okay. Let's talk about what? Aluminum and oxygen. Can someone tell me what's the symbol for aluminum? Can you take a guess? Come on. What's the symbol for aluminum? You can take a guess. Yeah. I mean, a good guess is what? Maybe it starts the same way, right? Aluminum, Al. You're right. Everyone, it's Al. Look. Aluminum. Oh, where is it? Aluminum is right here. And what's the next one? What's that? It was not called oxide. It used to be called what? What was the original name? Come on. Remember, this, everyone, I don't know if you can see this. Do you see how the first name stays the same? Do you see how the first part stays the same? Calcium, aluminum. What was the original name for this? It was not fluoride. It was what? It was not D. It was fluorine. What was the original name of this guy? Come on. No, it's okay. Right now, it's oxide. What did it used to be? Come on, what's the original name for oxide? The actual element name. You're thinking too much. What do you breathe? That's my point. The second name always changes. Everyone, the second name, there's an I here. It changed. It used to be INE. It used to be fluorine. This did not used to be oxide. It used to be what? Come on. It used to be what? This used to be what? Oxygen. When it comes second here, it has to change. It has to become IDE. These are the rules. I did not invent them. They were just there. Okay? All right. So I'm going to actually point this way. This is AL. Sorry, I'll make it a fancy L. Yes. What's the symbol for oxygen? Just capital O. Capital O. Okay. Everyone, let's, by the way, do not sketch anything yet. This is going to be a big sketch, and you'll see why. This will be a big sketch, and you'll see why. So let me actually open another Microsoft Paint and do this. Okay. Noah? I'll leave you, just don't worry. I'll give you time to copy, but I just want time to discuss this one, okay? All right. Everyone, what are we talking about? Which one is the first one? Come on. Aluminum and oxygen. Okay. Let's sketch. Again, don't sketch anything. This will take a little bit. What's the number for aluminum? How much? 13. Okay, let's quickly sketch. Let me just make sure. Okay. So 13. Where is it? Okay. Okay. So I'm going to sketch AL. And here's my nucleus for AL. Okay. Let's do one circle. How many? 2. Let me just move it. Okay, right here is a good spot. Another circle. 1, 2. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8. I'm up to how many so far? 2 plus 8 is how many? 10. I still have how many? I need to go up all the way to what? 13. So I need how many more? 3, right? Well, 3 more is definitely going to fit in the last circle. 1, 2, 3. Okay. That's it for aluminum. Let's go to oxygen. What's the number for oxygen? Oh, okay. So it should take less time. So O. I know it looks weird. This is the, I'm going to write it just ox to understand this is not a circle. This is just oxygen, okay? Okay. First circle is how many? 2. Second circle. How many do you think we need in the second circle? I need to get up to 8. I've already finished 2. I need 1, 2, 3, 4, 5. Hold on. Wait. I'm going to put it here and here. Are we good so far? Okay. Can you tell me what should aluminum do? How many circles does aluminum have? Come on. 3. 1. Everyone. 1, 2, 3. Is the first circle full? Yeah, it has how many? Is the second circle full? Has 8. No. Just the second circle. It has how many? 8. So it's full. How many dots do I have here? It should have how many? If you need 8 and you only have 3, how many more do you need? Is it making sense? Noah, come on. This circle has 3. But if it wants to be full, it should have how many? 8. So how many more does it need added to it? The last one. The last one. This one. I need how many? 5. Okay, so I can request 5, right? I can ask someone to give me $5 or 5 electrons. Is there another way to go about this? If someone, sorry? Okay, so one way you can do it, which is gotta be the wrong way, is to what? Take 5 from something else. What's another way? Give. But how many would you need to give? Not just that. How many would you need to give and which ones? You can't just give one of the last three or two of the last three. You have to give what? All three of the last three. Why would that be good? Everyone, if you lose this one, and you lose this one, and you lose this one, do you even, no, but do you even have the big circle anymore? No, you don't. How many circles do you end up with? Two. And are they both full now? Do you see what I mean? So again, remember, full does not mean take. Sometimes full means what? Give. Now, which one is easy? And now you have to decide. Which one is easier? To take 5 or to lose 3? It's always the smaller number, right? That's why it's actually better to what? To lose the 3 than to gain the what? Okay. Are we good so far? Hold on. Don't sketch yet. Now let's discuss what? Come on. Discuss what? Oxygen. What's the deal with oxygen? Is the first circle full? Yes. It has how many? 2. How about the last circle? It has only how many? But it needs how many to be full? 2. By the way, what if someone says, why don't you just lose the 6 and go back to how many circles? Again, which one is easier? To lose the 6 here or to just add 2 to them? Oh, okay. Now let's think. What did you say this one needs to do? Gain or lose? This one. Lose how many? 3. This one needs to gain how many? No, gain. 2. All right. How are you going to do that? Okay. Everyone, I have all of these. Okay, Rascal, just look at this. I have all of these coins. I am aluminum because I can lose, right? All of you are oxygen. Okay, tell me what to do. I can only give what? Each one of you can only request how many? Not just one. If you want to take, I have got to give you 2. Okay. We both have to decide. So let's say I give Rascal 2. Are you happy now? Because you're full, right? She got the 2, and she's a full what? She's a full final circle. I'm not happy. Because if I wanted to lose, I had to lose 3. Do you see the problem here? You got your end of the deal. I'm still stuck with this guy. And you might say, why don't you just keep it? Chemistry doesn't work that way. You have got to either fully lose or fully gain. So, all right, you're what? You're oxygen. And you need how many? I'm sorry, man. I'm 1 aluminum. I can only give 3. I chose to give her 2. Keep going. You're not wrong. Yes. I need a second partner in crime. But they have to be like what? Like me. So I need a second what? Aluminum. So I'm going to choose Alipio to be a second aluminum. All right. Alipio, you are aluminum and you have 3 to offer. Okay. I've given what? I had 3, right? I'm aluminum, you're aluminum. They're both oxygens. I'm aluminum. I've given 2 of mine to Rascal. And 1 of mine to what? To Muhammad. I'm out. I'm done. What would you need to do? You have 3. You have to give all 3. But how are you going to choose to do it? By the way, she has 2, so she's done. She's good. He has 1, by the way. He has 1. Give 2. If you give him 2, he already has 1.
Give 2 and she give 1.
No. Rascal is done.
Yeah.
Okay. So hold on. Okay. So far you have how many? Yeah. Okay. Give him 2. Problem is now he has how many? Right? Because he got 1 from me and 2 from you. But he cannot keep 3. He only can keep what? Great. Give him 1 back. Okay. So now Rascal is good. Muhammad is good. I'm completely out. You have how many left? What can you do?
1.
Yes. You choose 1 of the other oxygens Yep. Let's say you give it to Robert. Yeah, over there. Yes. Okay. Did I lose all of my 3?
Yes.
Did you lose all of your 3?
Yes.
Did you get 2? Did you get 2? Did you get 2? We're all happy. I lost everything I need to lose. You lost everything you need to lose. They gained, they gained, they gained. So what does that mean? To make this, how many aluminums did we need? 2 losers aluminum. And how many winner or gainer oxygens? 3. Do you see why I told you it's got to be tricky? It's got to be 2 of us connected to 3 of them. That's how it goes. All right. So how are we going to sketch this? Well, I mean, you be the artist, I guess. But we just have to fit 5 things, right? Because 2 aluminums and how many oxygens? 3. 1, 2, 3. So, but hold on. Before you sketch, we have to decide on a way to, because you don't just sketch, you also have to sketch the arrow to go wherever, right? Maybe this is a good way. I don't know. You tell me. What I'm going to do is this. Everyone, check this out. I'm going to select this guy. Look. I'm going to select this. Copy, paste. There we go. I'm going to make it, yes. So how many aluminums do I have now? Come on. 2. I'm going to make it a bigger space. Okay. So I'm going to move this one here and move this one right under it. Obviously, how do they actually look like in a real molecule or compound? I don't know. I'm just showing myself kind of like the math way of thinking about it. How to just line them up. But they probably would not just probably, most likely would not look like this in real life. Like if you have a microscope and you look at the atoms. Okay, let's copy this one. It's easy for me because I can just copy paste. You have to kind of like sketch. Sorry. There we go. Nice. All right. What should we do? That was me. That was Alipio. That was Rascal. That was Muhammad. And that was Robert. Can someone tell me how to sketch the arrows now? So what I'm going to do is this. Everyone look. These 2, I'm going to choose these 2 to go here. So that was me giving 2 to Muhammad. No, hold on. Yeah, to Muhammad.
Yeah, you keep
Yes.
two, then you give the other one to the
Yes.
middle.
And then me and Alipio are going to give this one and this one to Rascal. And then finally, Alipio fully still had 2 left, so he will give them right here. I know, it's got to be a little bit messy, but you know what? This is how chemistry is sometimes, not always. Sometimes it's clean, sometimes it's a lot. So let's see. I'm going to use this color. So what did I say? I said that this one is going to, oh, sorry. This one is going to go here. And this one is going to go here. Good. Now, this one is going to go here. And this one is going to go here. Well, you don't have to curve it that much. Very good. And finally, maybe this one's going to go here. My phone? Oh, okay. Come on. There we go. Beautiful and complete. There you go. That's the only way that aluminum would pair with oxygen. It never does it any other way. It's actually not, it doesn't just never do it. It's physically impossible. All right. What did we just do? Oh, yeah, okay. All right. Let's go back to everyone. The last thing for today, because we only have like 20 minutes. And honestly, I don't want to go all the way till the end. Okay, what's the next one? Yes, this. Okay, everyone. Now, oop, my bad. Okay. Okay, naming. What does naming mean? Come on. What does naming mean? Naming. Come on. Give it a name. Okay, giving a name. Now, let me ask you a question here, everyone. Can someone read this for me? Just read it. Seriously. You need to know how to read chemical names of compounds. Come on. Calcium fluoride. What is this one? Okay. Is it said calcium fluoride or fluoride calcium? Which one is it? Which way is it written? Calcium fluoride. How about this one? Is it oxide aluminum or aluminum oxide? Okay. Now here's my question to you. Which one is this one? Is this one the one that lost or the one that gained? Calcium. Hmm. According to the diagram, is calcium the one that lost electrons or the one that gained electrons? Just the diagram tells you exactly. Okay. And fluoride or fluorine is the one that what? Gained. Okay. How about this one? Is aluminum the one that gained or the one that lost? And oxygen is the one that gained or the one that lost? So tell me, according to this, oh, sorry, not this, my bad. Which one is always written first? The one that gained or the one that lost? Thank you. The one that loses electrons is always said first. The one that always loses electrons is written first, and the one that gained electrons is always said second, all the time. Here's a question for you. Hold on, before you do it. If you lost electrons, the one that lost electrons, does it become more positive or more negative? Come on. If you lost, you give away electrons. Do you become more positive or more negative? You become more positive because you gave away negatives. You gave away negatives. What about this one? This one gained electrons. So what does it become? They become more negative. Yes. So that means the way we're going to write it down is this. The way we're going to write it is this. Sorry. The positive ion, positive ion is always written first. You never write it second. The positive ion is always written first. You never write that 1 second, ever. Okay. Here's a very interesting thing. Can someone read this word again? Yeah. Again, you can break it down into maybe three parts. Everyone, you can say, look, you can say, hold on 1 second. You can say transitional. Transitional. Do you remember which ones of these? Oh, sorry. Which ones were the transitional or transition elements? Okay, hold on. Okay, let's quickly review. Who remembers what the name of these ones? I'll give you a hint. They refuse to react with anything else. They're like so high in society. These are called what? Noble gases. Do you remember what we call these ones? At least 1, 2, 3, 4. These four. What's the group before noble gases? Starts with H. Halo? Yeah. Halogens. These are halogens. And then we had do you remember what we call these? The yellow ones. These ones, thank you. These ones are the what? Transition minerals. You have to understand something, everyone, about transition minerals. They're weird. Why? Okay, aluminum. Okay, when I was aluminum, okay, when I did it with you and Rascal, when I was aluminum, what was the deal with me? I had to lose how many? Okay, and you had to gain how many? You can't do anything but that, and I can't do anything but that. How about calcium? Calcium had to lose how many? Calcium, sorry, not this one. Yes, calcium had to lose how many? Two. Oh, sorry, two. had to lose 2. And fluorine had to gain how many? Okay, so again, everyone, look. All of these elements can only do one thing, lose 1. All of these elements can only do one thing, lose what? All of these elements can only do one thing, lose how many? 3. All of these elements can only do one thing, lose nothing and gain nothing, because they're what? They're okay, they're full. When you're full, do you want to do anything? Exactly. These are full, they're done. They don't want to lose, they want to gain. These can only do one thing. They can only what? Gain 1. These can gain what? These can gain what? Okay. What about the deal with these? Okay. No, hold on. Everyone, transition elements, they mostly lose. They mostly lose. But here's the weird thing. They could lose 1 or you're like, hold on, that doesn't make sense. Aluminum can only lose what? It cannot lose just 1 or 2. It has to lose always what? 3. Those ones have to lose what? They can't just say, oh, I have 2 extra. No, they have to only lose what? These can lose only what? So they already have one way to do it, and that's it. These ones, do they have one way or multiple ways? Apparently, they could, depending on what? Depending on the reaction, depending on how you mix them with other things. Well, that gets confusing, right? Because now, okay, everyone, if I can lose 1, what can I do? Oh, I'm saying that also Rascal can accept also what? So I lost 1, Rascal accepted. Are we good? Okay. What if I need to lose 2? Then I have to what? Lose 1 to you, right? Now I lost 2, and you gained what? Rascal gained. What if I can lose 3? Or sorry, what if I have to lose 3? Do you see how confusing it gets? You need to know before you do the reaction. Before that, no, aluminum can only lose 3. So 1, 2, 3, and that's it, done. Okay? So, okay, what's an element known to have a lot of ways to go? You remember what this one's called? Cu. It's, remember, it's actually the wire inside of these. If you not cut it, if you take the rubber out, do you know what do you see inside? Copper. Copper wire. Everyone look. Come on, how many people have seen this before? But you never see it here. You also see, where is it? Outside or inside? Inside. Because can you ever touch this with your hand? Everyone, can you ever touch this with your hand? If it's connected to electricity, can you ever touch it with your? You don't want to do that, okay? Because this could pass a lot of electricity to your hand and you could get electroshock. But look at me. Is anything happening here? Why? Because it's wrapped in what? In plastic or in rubber, and rubber is a good what? Is a good insulator of electricity. Nothing's going to happen to me ever. But if I touch this, okay, if you touch it when it's not connected to anything, nothing's going to happen. But if you connect it and you touch it, ooh, good luck. You don't want to do that, okay? So copper is this element, okay? Copper, apparently, everyone, let's just look at this. Copper, oh, sorry, not this. Copper, by the way, I'm not going to write it down. We're going to write it tomorrow, but I'm just going to talk about it. Some transition metals can have more than what? More than what? Ionic, which means it could lose 1, or it could be +1. Sorry, 1 plus, or 2 plus, or 3 plus. Yes, not +3, 3 plus. Who can read this? This right here. Roman. What's this word? Numeral. Numeral. Numeral just means number. Numeral just means number. Numeral, number, they kind of start the same. How many people have seen numbers like this before? But how many people have seen it? You see it? What's this number? Come on, everyone. 1, 2, 3. Yeah, it's not IV, it's what? Do you know what 5 is? Just V. Everyone, 1. 1 is easy, it's just 1. When I look, 1 is easy. 2 is easy. 3 is easy. 4 is weird. It's IV. 5 is just the what? The V. By the way, usually capital. Okay? What does this tell you? If you use this, that means it loses how many? If you use this, it means it loses how many? How about here? How about here? And so on and so forth. Apparently, copper, by the way, this is wrong. This should not be +2. It should be what? Thank you. What does Cu2 plus mean? Did it gain or lose? When you become positive, what does that mean? You lost. How many did it lose in this case? 2. It actually had a bunch of them in the last circle, and it chose to only lose how many? It decided to lose 2. Okay? So we call it copper what? No, what's this number again? This number is 2, right? Yeah, you never say 2 as a 2. I did not make the rules, everyone. You have to use Roman numerals. Do you know what Pb is? Pb is what? Lead. What's this number? It should be what? It should be what? 4 plus. What's 4? IV. So whenever you see this, just use that. Whenever you see this, okay, question for you. What if this was 3 plus? Come on. What would I put in the bracket? 3 plus. What would I put? 3. What if this was 1 plus? What would I put? 1. So this number, only with these elements. Everyone, only with these elements. Look, everyone, only with these elements. You will never have to use it with what? With these ones, or with these ones, or with these ones, or these, or these, or these. It's almost always with what? With these ones. With copper, with zinc, with nickel, with cobalt, with iron, with manganese, with chromium, with tin. These ones can lose 1 or can lose what? Or these are the ones you have to use the what? The 1, the 2, the 3, the IV, and those Roman numerals. Okay? We're going to do more examples tomorrow.